This week, we delve into the world of the Spatial Analyst extension in ArcGIS. So we can use Spatial Analyst extension for a lot of reasons. It allows us to derive more information from existing data sets by doing more complicated analyses, answering more complex questions. So analyses that maybe you're interested in looking at, site suitability topics. So things like where's the best place to build a new store, or conversely, where do I not want to build my house if I want to avoid, certain soil types or slopes or things like that. We can take, using tools in the Spatial Analyst extension, we can take multiple criteria and consider them all at the same time to answer our site suitability question. Other analyses that you will find in the Spatial Analyst extension are all of our terrain analysis tools. So looking for things like slope of an area, what else? Managing risk based on the terrain, hydrology tool sets, all in the Spatial Analyst extension. You also can use some of the tools here to visualize patterns in your data. Any sort of spatial distribution within the data itself. So if you are interested in maybe where certain types of crimes are occurring within San Diego, you can look at the crime data and see if there's any patterns to different neighborhoods. Or you could, if you're interested in disease outbreaks, so what may be causing different disease outbreaks, or if you're looking for pre-existing conditions that may lead to diseases like diabetes or heart disease, you can look at that as well in pattern analysis. So in the exercises in the textbook this week, you are learning how to use some of the basic spatial analyst tools to answer some basic questions. Before we get into the tools you're using this week, I want to take a step back and do some review of the raster data model. If you remember from 110, we have a whole bunch of different data models you can use in ArcGIS. In 110, we spend most of our time using vector data, and so far this semester we have too. Last week we got an introduction to the TIN data model. And this week we're really diving headfirst into the tools that use the raster data analysis. So if you remember with raster data, unlike vector data, it is an array of grid cells, so columns and rows of grid cells, however many rows and columns you need. And each cell contains information about the feature that it's representing. So it's a little bit different, it's very different from vector data. So in the lecture, we review how raster data impacts data display, how it represents the real world phenomena on the Earth's surface. We'll also look at the importance of cell size and how that contributes to the quality and resolution of your image. And we'll also see some examples of different types of raster data and sources of raster data, and then the different formats of raster data that you can use in ArcMap. After we do that review, we can start diving headfirst into the exercises in the textbook about the Spatial Analyst extension. One note on the textbook, it assumes that you have a lot of background knowledge of raster data and some of these tool sets that we're using. If you are breezing through the exercise, just trying to hurry up and complete it and submit the assignment, you are going to miss a lot of the key concepts of why the tools were chosen, how they're applied, what the different parameters mean. Make sure when you are going through the exercises that you sit down and you really read those paragraphs, those intro paragraphs, and all the other text within the lab exercise. The lecture this week also goes into a little bit more detail on some of the tools we're using this week. So we'll look at the best practices for using spatial extension and your basic raster data analysis tools. We'll also go in depth on some of the tools we're using this week. So we'll look at extract by mask. We'll look at hillshade, which we looked at last week with the TINs, but similar this week to using it with raster. We also learn how to start creating density surfaces by using the kernel density tool. And what else? You'll also be learning how to reclassify your raster data. For example, if you are considering a site suitability analysis and one of your criteria for a suitable site is land use type, let's say you're looking to create a new subdivision out in the middle of nowhere, not in an existing area, but you just want a blank piece of land to develop. And you have a land use raster image that has maybe 15, 20 different land use types for all sorts of things like residential, commercial, maybe a bunch of different vegetation types, and then water. You can use the raster, you can reclassify the raster using the raster calculator. I'm sorry, you can reclassify the raster using things like broad categories like vegetation and developed land, undeveloped land, water. So you go from 15 to 20 categories down to 3 or 4 categories. And this can simplify your analysis and just give you that idea of good places to build, undeveloped, versus bad places to build, like water, probably be a bad place to build a new development. The last tool set you'll get into is very briefly the map algebra tool set. So how to use some of the different operators to better understand and combine your data. So it's a really broad overview of a lot of different tools within the Spatial Analyst extension. If you want more info on how to use the Spatial Analyst extension or how to do more complicated site suitability analysis, definitely take a look at GISG 112 because that's where we spend a lot of time with raster data and doing these analyses.